In this video, we're going to discuss the empirical rule. The empirical rule is a way to look at data and describe it, but it's only if the shape of it is bell-shaped. It's a normal distribution is what we call it, meaning it cannot be skewed right or left. And it also cannot be a uniform type of shape. Recall those shapes from back when we originally went over histograms. We had right skewed that looked something like this. We had left skewed. We had uniform that looked more like a box. And then we had the bell shape. The bell shape, basically what the bell shape is looking at is that we've divided it in half. 50% is on the right hand side, 50% is on the left hand side, and it gets smaller the percentage wise. So when we look at a bell shaped and we look at the mean is always in the center, then we add our standard deviations. Recall we just went over how to calculate standard deviations. So we're going to add one standard deviation, 2 standard deviations, 3 standard deviations. Then we're going to subtract it. So we're going to go smaller. The empirical rule says that overall 68% of our data values are going to be within 1 standard deviation in this big hump area. And you'll notice that as I look at the values of the percentages, they decrease because I don't have as much underneath that curve. So 68% lie within 1 standard deviation. Now you'll notice 34% on one side and 34% on the other. Because again, the mean, if it is a bell-shaped normal distribution, cuts it directly in half. So we have half of it over here, half of the 68% on the right-hand side. The empirical rule goes on further to say that 95% of our data will be within 2 standard deviations. Now you may be looking at how did we get 13.5% in each of these sides? Well, what we did was we took 95 minus the 68 that was already in that area. And so 95 minus the 68 is going to give us 27. And since I have it on both sides, I'm going to take 27% divided by 2, and that's going to give me the 13.5%. So 13.5% is between 1 standard deviation and 2 standard deviations on both sides. Again, the empirical rule goes further, saying that 99.7% of our data will be within 3 standard deviations. So here and here. So that means that between these two lines, we have 99.7% of our data. What we did to get this percentage here is to take 99.7 minus the 95, which gives us 4.7. And I'm going to take 4.7 and divide that by 2, and that gives me the 2.35% that lies here and here. The remainder is going to be 100 minus 99.7, which is 0.3. 0.3 divided by 2 gives me 0.15% on the outsides. The reason why we don't have an entire 100 within the 3 standard deviations is because we may have an outlier here or there. We may have outliers on both sides. This gives us that possibility on the outsides. Again, this is only good for the data that is normally distributed. And so we can estimate the percentage of data values that will be between two separate values. Let's look at an example of this. Okay, IQ scores of normal adults have a bell-shaped distribution with a mean of 100 and a standard deviation of 15. So what I've done here is I've taken the normal curve and I've put 100 in the center, and then I've added 15, which gives me 115. I've added another 15, which gives me 130. Add another 15, which gives me 145. On the other side, I took 100 minus 15, gives me 85. 85 minus another 15 gives me 70. 70 minus another 15 gives me 55. This has divided our data values, since we know that it's bell-shaped, into our different 1 standard deviation, 2 standard deviations, and 3 standard deviations. So whenever you're looking at bell-shaped information, look at the 68, 95, 99.7 rule, also known as the empirical rule. That tells me that 68% is within 1 standard deviation. So 68 divided by 2 gives me the 34% on each side. 95% is within 2 standard deviations. So this is 95%. 95 minus 68 divided by 2 is going to give me 13.5% on both sides. And then 99.5% will be between these two values, leaving me with 2.35% in each of these areas. And I have 0.15, not 0.5, 0.15% left over. Again, the reason why we want to look at these is because maybe we want to figure out how much is between two values, or what's the probability that something is going to fall between two numbers. So what percentage of adults have an IQ score between 55 and 145? So we're talking about between here and here. Well, this is 1, 2, 3 standard deviations. This is 1, 2, 3 standard deviations. So about 99.7% will lie between these two values. Approximately 99.7% of adults have IQ scores between 55 and 145. Because I've noticed that it's 55, 145, those are both 3 standard deviations away. What percentage of adults have IQ scores greater than 145? So we're talking about this portion of them out here. The portion out here that's greater than 3 standard deviations is the 0.15%. So approximately 0.15% of adults have IQ scores greater than 145. My recommendation is for you to go through some of the data that is normally distributed, that has that bell-shaped curve, find the mean, find 1, 2, 3 standard deviations in both directions, and kind of set you up a table like this so that you can begin to see those values. Let me know if you have any questions working on the empirical rule.